All right, here we go. Systems of equations. And this is elimination. And here's the deal. Everybody has a favorite way to solve a system. And we'll talk about, in a few days, we'll talk about when to use which way, right? Because we have graphing, we have substitution, which we did, and we have elimination. We'll talk about being able to identify when you should use each of the three. But elimination is the one that always works. Like graphing doesn't always work because what if you have a decimal, right? You know, you don't want to graph decimals. Well, if you have decimals, elimination will work. Substitution works, but the problem sometimes with substitution is that if you make a mistake, right, there's more room for error. So elimination is the one that people tend to use the most, okay? So elimination is exactly what it sounds like. What does it mean to eliminate? Get rid of it, right? To remove it. So we get rid of one set of variables. We get rid of one set of variables. So like we get rid of the x's. Or we get rid of the y's. It doesn't matter which one you get rid of, but you get rid of one set. And how do you do that? By combining like terms. So there are three levels of problems, right? There's easy, medium, and hard. We're going to start out with easy ones that are obvious. Then we're going to go to the medium ones, which are a little less obvious. And then we're going to go to the hard ones, which you have to do some math to get to. Okay? So, always, every single time, you're going to want to do this. No matter if it's an easy, a medium, or a hard problem. Every single time you are going to want to write the equations so the like terms line up vertically. Every single time, you want to write the equations so the like terms line up vertically. So let's do an example. Write the equations so the like terms line up vertically. And here's my system. Negative 5x plus 7y equals negative 8. And negative 2y plus 5x equals 13. Do the like terms line up vertically? No. Do I have to change the problem? I mean, the problem's not itself going to change. I just have to change the order. So negative 5x plus 7y equals negative 8. And I keep the first one the same, or I could have changed it, doesn't matter. And let's change the bottom one. So what can I change the bottom one to? 5x minus 2y equals 13. Now the like terms line up vertically. My x's are vertical, my y's are vertical, and my constants, my plain integers, are vertical. So every single time, and this is an easy problem. This is an easy problem because now all I have to do is combine like terms. If it's an easy problem, as long as my variables line up, I can combine like terms. And I'm going to combine like terms vertically. I'm going to combine my terms vertically. So if I draw a line underneath my problem, and I combine like terms, negative 5x and positive 5x make what? 0, so they cancel out. 7y minus 2y is what? 5y equals negative 8 and positive 13, 5. If it's an easy problem, I look at it and I say, oh yeah, my x's are opposites. I combine like terms vertically and I'm good to go. So now I solve for the variable. Zoe.
So do you do negative 8 minus 13 or do you just do negative 8 plus 13?
Plus 13 because it's a positive 13.
Okay, so you don't like subtract?
Nope.
Oh.
Solve for the variable. So divide by 5. So y equals 1. I'm halfway there. After you solve for the variable, you substitute the value into one of the original problems. It does not matter which one you want to do. So let's have the ladies substitute in the top one, and the gents substitute into the bottom one. It doesn't matter. You're both going to get the same answer. So I'm going to do it down here. I'm going to do both of them. Okay? So negative 5x plus 7y equals negative 8. And then I also have 5x minus 2y equals 13. You do not have to do both of them. Ladies and gents. Nope, you put it back into the original problem, so the x is still there. So you're taking your value that you just found, which is y equals 1, and you are substituting. So negative 5x plus 7 times 1 equals negative 8 for the ladies. And the gentlemen, 5x minus 2 times 1 equals 13. Focus, please. Substitute the values into one of the original problems. I don't care which one. What do you think you're going to do next? Solve for the variable. So after you substitute, that value you found into one of the original problems, you solve for the variable now. So my ladies are going to get negative 5x plus 7 equals negative 8, minus 7, negative 5x equals negative 15, so x equals 3. And the gentlemen are going to get 5x minus 2 equals 13, plus 2 is 5x equals 15, x equals 3. You get the same answer, no matter which equation you picked. What's our last step? The ordered pair. So what's the ordered pair? 3, 1. Right? An easy problem because it's an automatic cancelization, right? It automatically cancels out. So let's try a medium problem. We're still going to follow the same rules. So let's try a medium problem. All right, so let's label it. Oops, problem starts with a P.
Did you put a B?
Yeah, I got a head in my writing. All right, so here's my medium problem. Negative 7x minus 9y equals 25. And negative 3x minus 9y equals 21. This is a medium type problem. In my easy problem, if I combined like terms, something automatically canceled out. In this problem, if I combine like terms, I have negative 7x and negative 3x, that's negative 10x. And I have negative 9y and negative 9y, which is negative 18y. So nothing cancels out. But is there something that I wish, like, oh man, if that one thing was different, they'd cancel out? Right? Is there something that, oh, if one thing had changed, this problem would be an easy problem, right?
Yes.
If this negative 9 was a...
Positive 9.
So you can do this in math. I can change this, but what that means is I have to change everything in the problem. So medium problems are those ones where you look at it and you say, if only one thing was different. If only one thing was different, this would be an easy problem. Well, this is, in essence, what I'm doing is I'm multiplying by negative 1. Because multiplying by -1 changes the value of a number, correct? And if I multiply everything by -1, I'm good. You cannot just multiply one thing by -1. So what you do is you have the right. You can change it. But you have to change CHANGE everything. About the equation. If it's positive, change it to negative. If it's negative, change it to positive. You have to do it to all three values. And if you do it to all three values, then you're fine. You're good to go. So now, knowing the rules that we just practiced on page 1 of the notes, let's combine like terms. -7x plus 3x is -4x, right? My 9's y's cancel out. Equals 25 minus 21 is 4. What's my next step? Solve for that variable, right? Divide by -4. So x equals -1. Am I done? No, then I take that value and I resubstitute it into one of these equations. Here's my piece of advice. Because does it matter which one you pick? No, it does not matter which one you pick. My piece of advice is I like to pick the one either with the smaller numbers, right? Smaller coefficients, just because that's less multiplying. Or I like to pick the ones that do not have negatives or have the least number of negatives, because negatives sometimes give us problems. Some people say, you know what, forget it. I'm just always going to substitute into the top equation. And that's fine. Because it does not matter which one you substitute into. They will both give you the same value. Anna. You can use either one. You could use the original problem, so that's a good question. You can use the original problem, which was -3x minus 9y equals positive 21. Or you can use the new problem of 3x plus 9y equals -21. So really you have three choices in this problem, right? But any of them will work. Anna, which one do you want me to do? Okay, top. So -7 times -1 minus 9y equals 25. Which is 7 minus 9y equals 25. Which is -7 minus 7 -9y equals 18. Y equals -2. And my final answer is, flip it. Oh, maybe then you said it right, Dylan. I didn't hear. -1, -2, because my x value is -1, my y value is -2. And we're actually going to put the hard problem on its own page, just because I don't have enough room down here.
If we have room, can we write it on
Okay, we may. We'll try it. I'll post-it note it if.
How many problems are on the homework?
6. Too easy, too medium, too hard. All right, here we go. Hard problem. Thank you. All right, and a hard problem is called a hard problem because if I look at it, negative 2x no, let's change that. Positive 2x. Sorry. Minus 14y equals 16. And x minus 7y equals 10. So it's a hard problem because does anything automatically cancel out? No. Is there anything that I think to myself like, oh, I just wish that had been positive? No. So there are two ways to do this. I'm going to teach you the general way. Okay? The rule that works every single time. If you're really good at knowing the factors of numbers and multiples of numbers, we can talk about the second way, but this way is going to work hands down every time. Okay? Here's what you do. You multiply the top equation by the bottom x coefficient. Multiply the top equation by the bottom x coefficient. Multiply that every single time. Anytime there's a hard problem, if you use this step or these steps, there's more than this, you'll be able to solve it. So if I look, the top equation is going to get multiplied by the bottom equation's x coefficient. What's the x coefficient? 1. And for the sake of our notes, let's talk it through. 1 times 2x is 2x. 1 times negative 14y is negative 14y. Equals 1 times 6 is, or 16 is 16. Multiplying by 1 doesn't really change anything. But is your x coefficient always going to be 1? No. Multiply the top equation by the bottom x coefficient. Multiply the bottom equation by the, here's the trick, opposite of the top x coefficient. You've got to make it so that they cancel out. Something cancels out. So if I multiply the bottom by the, or the top by the bottom x coefficient, and the bottom gets multiplied by the opposite of the top, something's going to cancel out. Multiply the bottom equation by the opposite of the top x coefficient. So that means the bottom equation gets multiplied by, instead of 2, it's going to get multiplied by negative 2. So that means negative 2 times x is negative 2x, and look what happened. And negative 2 gets multiplied by negative 7y, which is 14y, equals negative 2 times 10 is And now it's an easy problem. I can combine like terms. Now this on top of it is a special problem, right?
How did it become -2?
That's the rule. It's the opposite of the x coefficient. This is a special problem. What happens? 2x and 2x cancel out, right? Negative 14y and positive 14y in this problem cancel out. It doesn't happen very often, but it does. So what's left over on the left side? 0 equals negative 4. What kind of problem is this? How often does this happen? Not very often. What if it said 0 equals 0?
All real numbers.
All real numbers, right? Infinite solutions. Not all real numbers, infinite solutions. This doesn't happen often. Most of the time what happens, you follow these two rules and you get an easy problem and you now know how to solve the easy problem, right? You combine like terms, solve for the variable, substitute that into one of the original problems. In this problem, you have two original problems or you have two different problems. You have 4 choices for substituting here. All 4 choices will give you the same solution.